Okay, 2.2b, operations with rational expressions. This time we're going to talk about addition and subtraction. So here are some steps in order to add and subtract rational expressions. So first of all, factor in anything that you can, numerators and denominators. Okay, we always want to state restrictions on the variables. And then I usually leave this till last, even though it should probably be done in the second step before we cancel stuff out and then you forget about it, but I always leave it to the end. We need to find the lowest common denominator, okay? When we do addition and subtraction, we must have a common denominator in order to add or subtract the numerators, okay? And we have to apply this to each term, and then we can go ahead and add or subtract the numerators, if possible, right? So as a reminder, keep the denominator as is, and then just simplify. Okay, so for the following, we're going to simplify and state the restrictions on the variable. So this one's easy because all the denominators are x squared. So what we do is in the numerator, we collect the entire numerator and we put it over the one common denominator. So 5 minus 2, we get 3 plus 3y over x squared. Now the restriction on the x is x cannot equal 0 because x is the only variable ever in the denominator. Okay, next one. The denominator can also be, instead of a monomial, it can be a binomial. So we can collect the top. So I personally bracket these and I'll show you why. So we get 4x minus 1. But we're going to actually subtract this entire expression. So what happens is a lot of individuals will put the negative sign right on the 3x, but it's also going to be distributed to the 2. Okay, so we get 4x minus 1 minus 3x minus 2. And this simplifies to 4x minus 3x is just x. Negative 1 minus 2, I get negative 3. And now we can put a restriction on the denominator. So the denominator, the x cannot equal negative 5, because if so, the denominator would equal 0. Okay, C. Here comes the skills from elementary school. We have 2 and we have 4. The lowest common denominator is going to be the 4. So we're going to actually multiply the first number by, we're actually multiplying by 1, but it's going to look like a 2 over 2, right? Because remember, 2 over 2 is just 1. So we're not actually changing the number. We're just making it look a little bit different. Okay? When we do this, we must distribute the 2 into this bracket. So I get 4x minus 10 over 4, and then we add x minus 3 over 4. Okay, they have the same denominators, so we can just go ahead and collect all of the numerator. Okay, I just rewrote it here. You don't have to. 4x and x gives us 5x. Minus 13 over 4. Okay, here's the thing. Is there a variable in the denominator? No, there is no variable. So therefore, x can be any number. We only put restrictions on the denominator. All right. D. So I'm going to bracket the numerators. And I want to throw this out there. This comes up very often in math where you have x minus 7 and then it's the flip, okay? So if we were to, for example, I'm going to just rewrite the numerators. X plus 4 plus x minus 5. Okay, I'm going to leave x minus 7, but if we were to, in the second one, factor out a negative 1, instead of having negative x, we would have x. And instead of having 7, we would have negative 7. So the denominators are almost the same. The only difference is this constant of like -1, the monomial. So what we're going to do is we're going to multiply this first fraction by -1 over -1. That gives us a denominator that's identical, -x minus 7. Okay, so we can collect the top. We get -1, x plus 4, I'm actually going to rewrite it, plus x minus 5. So this -1 can distribute into the bracket. -x minus 4 plus x minus 5, and that's all over -x minus 7. Okay, the x's cancel, and we get -9 over -x minus 7. And then these negatives can cancel. Okay, and the restriction here is just 7. All right, E. We have a b squared and a squared b. So what we're going to do is our lowest common denominator is going to be, when they're monomials, is going to be the variables with the largest exponent. Okay, so a squared is in the second fraction, so we're going to multiply the first term by a over a. And we have a b squared in the first fraction, so we are going to multiply the second term by b over b. This way, we're going to get 2a plus 4b in the numerator, and in the denominator, we're going to get a squared b squared. Okay, I want to highlight this. Do not cancel anything out. Okay, the numerator is not fully factored. Everything must be multiplied or divided in order to cancel them out. This is added. We cannot cancel this out. This acts as one big term. Okay, so A cannot equal 0 and B cannot equal 0. All right, last one. We have a constant 4. This is over 1. So the lowest common denominator is xy. Okay, so this middle term here has an xy in the denominator. The last term we'd have to multiply by x over x. And the first term we have to multiply by xy over xy. Okay, so we get 4xy minus 3 plus x squared. And that's all going to be over xy. Again, because there's plus and minuses on the top, this acts as like one expression, full expression, and nothing's identical in the denominator, so we can't cancel out. X cannot equal 0, y cannot equal 0. Okay, example 2. Simplify each of the following and state the restrictions on the variables. So, likewise, we're just going to continue. So, in the first example with 5a, 2a squared, and a cubed. So, when we talk about the coefficient, the lowest common denominator is just going to be like 5 times 2, which is 10. Okay, so we have to make all 3 of these 10. Okay, so we're going to multiply all of these by a constant. The first one to make it 10, 2 over 2. The second one, 5 over 5. And the third one, 10 over 10. Now, our variable component is going to be a cubed. So for the first term, we have to multiply by a squared over a squared. The second term, a over a. And the third term, it already has an a cubed in the denominator. So let's multiply each one of these terms. So we get 8a squared over 10a cubed. minus 15a over 10a cubed, and then plus 10 over a cubed, 10a cubed. Sorry, I forgot that one. Okay, now we can collect the numerators. So if we take a look at the numerators, none of these are like terms. So it's just going to be the expression 8a squared minus 15a plus 10, and it's all going to be over 10a cubed. Okay, and the restriction is a does not equal 0. Okay, the next one. So I don't quite know what these denominators look like, so I'm going to first factor them. Okay, so let's factor to 3, and we have x minus 4. And then I'm going to factor out a 4, and we have x minus 4. So the x minus 4s are common, so that's good. But the 3 and the 4 aren't common. So in order to get this, like the lowest common denominator, the lowest common denominator is actually going to be 12x minus 4. The x minus 4s we already have in there, so that's good. We're going to multiply the first term by 4 over 4 in order to get that 12, and the second term by 3 over 3, again, in order to get that 12. So we get 20 minus 21, and it's going to be over 12x minus 4. To simplify 20 minus 21, I just get negative 1 over 12x minus 4. The restriction is only going to be on the variable part, so x cannot equal 4. Okay, C, let's do the same thing. We'll leave the 7m and the 2m in the numerator, and let's factor the denominator, see what we're actually dealing with. 2m minus 2, and we have 4m plus 1. Okay, so for the constant part, the 2 and the 4, the lowest common denominator is going to be the 4. And then these brackets are not equal, so we're going to have m minus 2, m plus 1. This entire expression is going to be our denominator. So let's multiply the first rational by 2 to get the 4, and then also m plus 1. It's getting a little messy. M plus 1. Okay, let me do that first. So I get 14m, m plus 1 in the numerator. So 14m, m plus 1 over 4m plus 1, m minus 2. Okay, and then the second rational, we're going to multiply by, we don't have to multiply the 4. We have m plus 1, so we just have to multiply by m minus 2 over m minus 2. So I actually get 2m, m minus 2, and then over the same denominator, 4, m plus 1, m minus 2. Okay, in the next step, I'm going to distribute the numerators, and I'm going to write over a single denominator. So I get 14m squared plus 14m plus 2m squared minus 4m all over 4m plus 1, m minus 2. Common denominator. Okay, I'm going to collect these. I get 16m squared and then plus 10m over m plus 1, m minus 2. And we can factor out, what can we factor out of the numerator? Just a 2 actually. Oh, there should be a 4 here. So I get 8m squared plus, oh, I can factor out a 2m. So we get 8m plus 5, and that's all over 4m plus 1 Okay, and this is over 4m plus 1, m minus 2. So the only thing here we can cancel out is this 4, and we get m, 8m plus 5 over m plus 1, m minus 2. Okay, now restrictions. M cannot equal -1 or 2. Okay, so for D, E, and F, what we want to do is we want to factor wherever we can. So for this one, I get 7x over, and if you factor the denominator, you get x minus 4x plus 3. And then we get 4x. And if you factor the denominator again, x minus 1, x plus 3. Okay, so we need a common denominator. So x plus 3 is already common. So this x minus 1, we're going to have to multiply the first term by. And this x minus 4, we're going to have to multiply the second term by. So we get 7x bracket x plus 1 minus 4x, x minus 4. And then we have one whole denominator that is common. I put plus, but it's a minus. Sorry, x minus 1. So I get x minus 4, x plus 3, x minus 1. Now we can distribute the numerators. I get 7x squared minus 7x minus 4x squared plus 16x all over x minus 4, x plus 3, x minus 1. So 7 minus 4, I get 3x squared, and negative 7x plus 16x, I get 9. Okay, over x minus 4, x plus 3, x minus 1. So to double check if anything cancels out here, let's factor the 3 out of the numerator. So we get 3x squared plus 9. No, so that's not identical to anything in the denominator, so that's as simple as we can go. So we have x does not equal 4, negative 3, and 1. Okay, for E, again, we're going to start by factoring the numerator here and then the denominators. So I get 2x, and then I get x minus 1 left in the bracket over x plus 5, x minus 1. And 12x is normal, and we're going to factor out the 4x plus 5 here. So the x plus 5s are identical, so we leave that. And what we're missing is a 4 in the first rational expression. So multiply the top and the bottom by 4. And we're missing a x minus 1 in the second rational expression. So multiply both the top and the bottom. That way, we're basically just multiplying by 1. Nothing's actually changing. So I get 8x, x minus 1, minus 12x, x minus 1. All over, and we just collect these now, 4x plus 5, x minus 1, that's it. So let's distribute in, and we get 8x squared minus 8x minus 12x squared plus 12x, and that's all over 4x plus 5, x minus 1. Okay, let's collect like terms. So what is 8x squared minus 12x squared? I get negative 4x squared. And what's negative 8 plus 12? I get plus 4x. Okay, that's all over 4, x plus 5, x minus 1. Okay, now let's factor the numerator here. And I get, let's factor out the negative 4x. And we're left with x minus 1 in the bracket. And then 4x plus 5, x minus 1. Okay, the x minus 1s can cancel and the 4s can cancel. So I get negative x over x plus 5. And if we revisit anything that ever occurred in the denominator, x cannot equal negative 5 or 1. Okay, and that comes from our full denominator. Okay, I'm going to move f over. Okay, so for f, we're going to start with factoring the denominators here. Okay, so we have a binomial on the top, which is fine. Okay, I like to bracket those so that they're together. Okay, and for the first one, what two numbers multiply to negative 3 add to 2? I get x plus 3, x minus 1. And for the second one, I get what two numbers multiply to 4 and add to 5? Okay, I get 4 and 1. So for the second one, we're going to do decomposition because the coefficient of x squared is not 1. Okay, so 4x plus 1x. We broke down that 5x into 4x plus 1x. And now we're going to factor by grouping. Okay, if you need a factoring review, please see the factoring review on the site. So I get a factor of 2x, I'm left with x plus 2. A factor of 1, I'm left with x plus 2. Okay, those two are the same, so x plus 2, and what's left over is 2x plus 1. Okay, so if we see here, these two factors, wrong one, can go away. And don't forget, we still have to put a restriction on this factor here, okay? So let's just rewrite x plus 1 minus 1 over x plus 3, x minus 1. And then this is 2x plus 1. Now, for our common denominator, it's going to actually include all three of these brackets. So it's going to include x plus 3, x minus 1, and 2x plus 1. Okay, so the first number is missing this 2x plus 1 in the denominator. So let's multiply it by 2x plus 1 over 2x plus 1. Okay, that gives us a numerator of 2x plus 1, bracket x plus 1. Now the second number is missing an x plus 3 and an x minus 1 in the denominator. So we have to multiply by x plus 3, x minus 1. Okay, which gives us the minus x plus 3, x minus 1. Okay, in this step, we have a negative sign here. So we can't cancel anything out because not everything in the numerator is multiplied. It must be multiplied in order to cancel with the denominator. So we are going to FOIL. I get 2x squared plus 2x plus x plus 1 minus, okay, so let's do 2 at a time. So x squared minus x plus 3 minus 3. Oops, 3x minus 3. Okay, and same denominator, x plus 3, x minus 1, 2x plus 1. Okay, so let's distribute this negative sign into that bracket. So I'm just going to rewrite this. So minus x squared plus x minus 3x plus 3. And again, denominator is not changing. Just rewrite it as it is. Okay, now let's collect like terms. So 2x squared minus x squared, 2x plus x minus 3x, so those all go away, plus x, so I get a plus x here. And then 1 plus 3 is 4. Okay, and again, just rewrite the denominator. I want to point out that if you try to factor this numerator and you say what two numbers add to multiply to 4 add to 1, well, neither pair that multiply to 4 add to 1, so this is not factorable, so we're done. Now we have to write restrictions. Okay, so the restrictions on x plus 3 is -3. The restriction on x minus 1 is 1. And the restriction on 2x plus 1 is -1/2. Okay, don't forget, way up here, we had canceled out an x plus 2, so there's also a restriction of -2. Don't forget this restriction.